Hi, Assalamualaikum and a very good day to everyone. My name is Muhammad Najmi bin Ibrahim and metric number is 190440. I am a final year student of civil engineering from Universiti Putra, Malaysia. I am here to share to all of you about my final year project entitled The Effect of Vehicle Vibration to the Slope Stability along Kilometer 149 Lebuh Raya Pantai Timur 1. Introduction. Lebuh Raya Pantai Timur 1, or also known as East Coast Expressway, is the shortest highway that connected Kuala Lumpur to east coast of Peninsula Malaysia. The highway road is constructed in hilly and mountainous area and required a lot of cutting hills as a solution to allocate the best alignment and safety design for the road user. The traffic volume is expected to increase along the highway leading to East Coast during every festival celebration and school break, as those living in Kuala Lumpur return home for the long festival break and holiday. So, the vibration produced by the vehicle repeatedly and continuously can affect the slope stability when subjected to vibration for a long period of time. Moving on to the objective. The main aim of this project is to determine the effect of vehicle vibration from vehicle activity to the rock cut slope stability at Lebuh Raya Pantai Timur 1 (LPT1) along kilometer 149. The objectives are to determine the vehicle volume and characteristic during Malaysia public holiday. The second one is to investigate the relationship of vehicle activity and slope stability. Third one is to determine failure mode of the rock cut slope using software analysis, and the last one to determine slope stability in terms of factor of safety. The method of this study is divided into two, which are discontinuity survey and rock and soil sampling for laboratory testing. This continuity study focuses on collection of data such as dip and strike, vehicle volume, and vehicle speed was done during the Federal Territory Day, which one of the Malaysia public holiday. Rock and soil sample will undergo laboratory testing to determine the characteristic of the rock slope when subjected to vehicle vibration. Moving on to the result, the graph shows the data of traffic volume for every 1 minute interval. Traffic volume counted was separated by 5 vehicle types, which are motorcycles, car types, light truck, heavy truck, and bus type. Volume of the highway is dominated by car type, which are contribute 80 to 90% of the total volume. Results show that traffic volume toward east is slightly higher than traffic volume toward west. Traffic flow volume toward east direction have an average of 15 PCU per 1 minute, with highest volume is 32 PCU per 1 minute, while traffic flow volume toward west direction show an average of 14 PCU per 1 minute, with highest volume is 29 PCU per 1 minute. This means, according to the traffic volume for every 1 minute, the rock cut slope will undergo the average of peak ground acceleration produced by moving vehicles from average about 15 times every minute, and 32 times per minute is the highest PGA. The East Coast Expressway 1 road that provide 2 lanes, 2 ways directions road with maximum capacity of 4,000 PCU per hour per direction, but the PCU volume during the holiday was about 1/4 of the total capacity, so traffic jam is not expected to occur on the road during holiday. The peak ground acceleration felt by the rock cut slope only comes from the effect of vibration from moving vehicles. For the graph of peak ground acceleration versus vehicle loading types, it shows that range of peak ground acceleration for types of vehicles. The amplitude of vibration produced is very dependent of vehicle loading. Motorcycles which have lowest vehicle loading show the range of PGA produced from 2.5 to 3 times 10 to the power of negative 3 G. G is the unit for ground acceleration, not gram. Range of vibration produced by car from 3 to 4 times 10 to the power of negative 3 G. Most of two-axle vehicles are grouped as car, including multi-purpose vehicle (MPV) and sport utility vehicle (SUV). Heavy truck produce PGA range from 5.5 to 7 times 10 to the power negative 3 G, which is the highest PGA value detected at the site. This is because heavy truck can carry loading up to 40 tons that produce highest vehicle vibration. Another highway characteristic that induce vibration is speed. Generally, vehicle moving with higher speed will produce higher volume of PGA. Graph of peak ground acceleration versus speed show peak ground acceleration value for vehicle moving different speed separated with the vehicle types. Type of vehicle loading produce various maximum value of peak ground acceleration, but it is also dependent on speed. Graph plotted based on data collected at kilometer 149 East Coast Expressway. Motorcycle with the highest speed of 132 km per hour can only produce peak ground acceleration value of 3 times 10 to the power of negative 3 G, while heavy truck with higher speed of 109 can produce peak ground acceleration value up to 7 times 10 negative 3 G. Moving on to the astronaut data, the data collected at the first berm of the cut slope where it is predicted to have highest effect due to the vibration. Based on the result, two types of failure mode can be appeared on the first berm of the rock cut slope, which are plane failure and wedge failure. In the presence of vibration from the vehicles, it is possibility for the slope to failure in a mode of planar and wedge. Factor of safety of the slope stability analysis with presence of seismic load was calculated using software. For the slope stability, we consider the microseismic, which is vehicle vibration value. The result analysis from 4 different methods give various value. Sarma method give factor of safety 1.25, Spencer give factor of safety 5.06, Janbu give factor of safety 1.37, and last one Morgenstern Price give factor of safety 1.7, which are all value are greater than the minimum value of seismic analysis 1.00, and it is acceptable. In general, with the vehicle vibration load condition, the slope is just above the safety factor and it is safe for current time. But in presence of extra vibration load or with help of other factor that reduce factor of safety, the slope can be unsafe and failure can be occur at any time. Conclusion: magnitude of vibration produced depend on vehicle characteristic. Generally, increasing vehicle volume will increase the possibility of the cut slope to fail. The effect of vibration to the cut slope should be monitored to avoid occurrence of future landslide. That's all from me. Thank you.